editors to look. Specifically, the syntactic elements of the language that you're writing are color-coded, so to say, are highlighted in different colors, giving you an additional source of context as you're reading the code, whether a given word is a variable, a type, part of a command, part of a string. And how these kinds of highlighting code like this in an editor is a problem in itself. People are getting expecting quite a lot from their editor these days. Like they're not just supposed to highlight strings and keywords anymore. They should also do context-sensitive things, like whether something is a type or a regular variable, whether it's a local variable or a global, and so on and so on. So yeah, defining these is not entirely trivial, especially since if you're writing an editor, you don't have to deal with the quirks of one language, you have to deal with the quirks of every language. And while programming languages do tend to follow a certain kind of disciplined grammar structure, most of them at least, every single one has some weird exceptions and weird rules that don't fit into most generalized parsing frameworks. So this isn't trivial. CodeMirror comes with support for, which is my editor, comes with support for over 120 different languages, with some of them having a bunch of sub-dialects as well. That is quite a maintenance burden, and thus I set out to try and find a less error-prone and more convenient way to define these. In a way, these are parsers, as in they do a lot of the same work that a normal parser that you might find in a compiler does, but they have very different constraints. So a file might be big, but instead of parsing it in one go, you'll have constant localized edits, usually around one place. And like, it's not necessarily a parse tree, but a token stream, it has to be updated for every change, quickly preferably, because yeah, you don't want to freeze the interface that the user is using. People also find it annoying if it's like black for a few seconds and then flips into coloring. So you have to be able to respond to localized changes immediately. The input will often not be valid. As you're editing a text file, you're not going to have it in a syntactically valid form all the time, and you still want highlighting to more or less work, even if you make a mistake. I think every editor has a solution that relies on incremental parsing. So you have your parser state as a value that you can save and that you can resume multiple times, so that you keep your parser state at different positions in your document, and as it is edited, you just resume the nearest state and parse from there instead of always starting from the start. Of course, saving all these states has to be relatively low memory. You can't save a giant data structure X times. It's just it's going to take up way too much memory. One requirement that is more cumbersome than it might initially sound like is it has to have a low granularity. Many editors use end of line as a resumption point, which is not an ideal situation for the reason that a line can be several megabytes long if you have a weird minified file or something. But that's what a lot of editors do. So if you have, say, a comment that's 1,000 lines long, you want your parser state to be, stoppable even in the middle of this, which you would conceptually consider a token. You can't just go one token at a time, basically, in the traditional sense. And of course, it has to be error tolerant, which I'll get back to later. One way to conceptualize such a highlighter is to see it as a function from a given state and an input position to a token, which is like a little piece of this input with styling applied, and a new state after that token. And then you can just repeatedly call this function as you iterate through the document, and occasionally set aside a state for later resumption. I made a little animation which is trying to show this. So here you have a document. The blue stuff has been highlighted. The black rectangle is your viewport. So as you start up, you're only seeing a little piece of the document, so you don't want to go off and highlight the whole thing, because it might be 20 megabytes and the user might never look beyond the 5th line. So you start by just highlighting the first screenful, and then as you scroll down, you can like slowly continue highlighting. This is all still relatively like incremental. You don't have to do a lot of work in one shot. And when the user makes a change, say the red line changes, you throw away all the information below that change and take the nearest state above that change and continue to the end of the viewport from there. So this has a nice property that if changes happen within the viewport, which is the case at least 90% of the time, the work you have to do is bounded by viewport size, so you don't have to do, and you can usually just do it synchronously as you refresh the screen. Because it doesn't always hold up. Say you're looking at the bottom of the view and you have a collaborative editor and someone else is changing the first line. So you do want to set things up so that this work can be done in the background, and the user can keep on editing as some background process is catching up to the code you're currently editing. You can usually even cheat, like highlighting is somewhat state dependent, but not hugely state dependent. So if you are at the bottom of the document and you want to draw something, but you don't have a suitable state, you can just make up some state and start highlighting, and then later as your background thread catches up with your position, you can fix whatever is different. So if someone added a block comment marker on the first line, then yeah, the whole document will look differently, but usually it'll look almost the same. So you don't need to immediately get the accurate state. The techniques that exist for this are a common one which my editor uses is just write a function like the one I described before by hand, which maintains the state manually and is a lot like souped up tokenizer basically. The only other system that seems to do this is the IntelliJ family of IDEs. They also allow people to write a Java program that does, well, is basically a tokenizer with a state and can do some limited, like has limited access to the input stream and needs to return one token at a time. The downside of this is that it's like cumbersome to write a new mode, error prone. You can't really expect the average user who has a problem of needing to highlight a new language to write this, and it's one of the reasons why this huge massive modes for CodeMirror is quite a maintenance burden. They're often copy-pasted messes by people who didn't really understand what they were doing. The upside is that it's very powerful. It's hard to write a framework that captures all the possibilities that you have if you just write a program by hand. Then the older editor systems like Emacs and Vim, they kind of show the history of this, where at first it was like state of the art to highlight just keywords and strings and maybe comments, and then expectations increased, so they started with some ad hoc clutches to do just that, and then they added more clutches, and then it's not pretty. I don't understand them entirely because they're just too weird, but these are not systems that we want to be replicating. More modern editors, they all have a very similar format. Some even are compatible among each other, like Sublime Text, Visual Studio Code, Atom, and I think the one that pioneered this approach is TextMate. They have a format which basically allows you to define a number of contexts, and from each context you have a number of regular expressions which define if you are in this context and you see this regular expression, it's that token. And in addition to like defining a token, these regular expressions can say, and then you have to enter this context or you have to leave the current context, something like that. This is a relatively nice format to work with, a lot better than the alternatives and relatively succinct. But it's not entirely general in that it's really painful I was showing an example actually, to express sequences of things. So this is a very simple like operator expression languages, which has like numbers, variables, and operators and parenthesized expressions. So the starting context is expr, and it says if you see digits, call it a number. If you see letters, call it a variable. If you see a parenthesis, move to the parentheses context. And if you see an operator, just continue here. And then the parent expr context just says if I see a closing parent, go back. So this tracking of context is kind of useful for things like indentation and sometimes also styling. But what this, for example, doesn't express is that an operator is supposed to appear after a variable or a digit. So it couldn't, for example, distinguish between unary and binary operators. You can kind of make it do that, but things get verbose very quickly because you're basically building up a complex graph and you're doing it manually, like allocating names for all the edges and building the transitions manually. It's not a lot of fun. So my idea was we have a relatively good idea of how to write grammars in like context-free grammar style grammar notation. This has the advantage that the kind of hierarchical relations between things are naturally expressed. You just get like a new production, which is, for example, a parenthesized expression, and you can at any point know whether you're inside of that. It's much better about expressing sequencing because grammars tend to have a sequencing operator, and much more succinct, and even more importantly, you don't have to mess with regex. So these are trivial regex, but usually you'll be doing all your like kludgy things in a regex, and that just doesn't scale. They get hugely unreadable, complicated, and big. So we want something where a user can write a grammar, and then there's a little tool that compiles it into a machine, something like this. And then the editor can run that, and it should become a lot nicer to write such grammar. So this is an example of what my syntax looked like. I based it on parser expression grammars rather than context-free grammars, which are somewhat different in that in a context-free grammar, if you have a choice operator, so the pipe usually, it means basically these are all tried in the same, you really have to start talking, by the way, because at some point I'll just be like finished and they'll, so if you have something to say, just raise your hands. The choices are all basically conceptually parsed at the same time, and if multiple ones match, there's an error, an ambiguity, whereas in parser expression grammar, it's more like algorithmic. It says, try this one first, if it matches, that's what we got here, otherwise try the next one, and so on. And similar with repeat operators like plus and star and question mark, it'll greedily match as many as possible and then stop, rather than trying to like see if one matches, if the like parse multiple variants and then see if there's an ambiguity. This is on the one hand nice because it allows you to treat a grammar more like a program and hack around with it and without getting ambiguity errors all the time. On the other hand, it's kind of a food gun because it's very easy to accidentally have an earlier, like if you put your identifier rule before your keyword rule, then all your keywords will be seen as identifiers because they match the same like lexical syntax. So it's kind of a trade-off, but for my purposes it seemed to work pretty well. Another thing that these style of grammars have, I didn't include any here because I didn't need one, but they have a look-ahead operator, which becomes really useful when you want to disambiguate things that kind of look similar. And then probably the most important thing is that there's no separate tokenizer. This grammar is the whole grammar. There's no need for a tokenizer. It expresses the tokens in the grammar. So it's scannerless grammar, so this is usually called. And that's nice because it removes one context. You don't have to worry about writing a tokenizer and a grammar. You just write your grammar and you're done. And on the other hand, this has the property that grammars without a tokenizer can be combined. They compose, like they're closed under extension and embedding, and it's much easier to mess around with these. For example, if you have a C grammar and you want to build the C++ grammar, you can start from the C grammar and just add more rules and extend some existing rules. Yes?
Speaking to C and C++, does this system handle the business in the C grammar where you need to know whether a particular token is a thing or a term?
So one of my first grammars I tried to write with this is a C and a C++ grammar, and it's not stateful in that way that you can keep a symbol table, so I have to use a terrible hacker. I try to syntactically distinguish them by looking ahead, seeing if there's type expression and then an identifier, and then it's going to be one of these horrible C type declarations. This is not 100%. Like there are things like foo space star space something where you just don't know what it is. It could be a multiplication, it could be a declaration of a pointer. But so I use, like, if there's a space on both sides, it's probably an operator. If not, it's probably a type, and it works for most code. But yeah. You could, even if you had a symbol table, you don't want to go ahead and include files from your mode somehow and parse those. That would be impossible anyway. So you're basically stuck with ugly approximations like that for the C.
Any more questions?
If I'm using something, if I'm trying out a research language or something like something where there isn't editor mode support, I might not want or be able to specify the whole grammar like this. If I just wanted to get the keywords and maybe some, I don't know, maybe some other things are simple to find,
yeah.
Like say numbers or variables or types, if they're capitalized or whatever. So is this possible as well?
I would say that this is also a relatively nice format for this. You would just write a grammar that is basically a stream of tokens. So you would say token equals string, number, variable, something, keyword, well, keyword before variable, of course, and or an underscore, which is like any character, and then that's with a plus or a star after it, and it'll just continue matching tokens throughout your file, and that's pretty much what you need in that case. And I think it's still more succinct than the regex syntax for that.
So continuing on the previous question, this can then also be used for code snippets, like snippets taken out of context?
No, it doesn't do that. Like, that requires you to define kind of templates with holes in it, and you can't really derive those from a grammar. I mean, maybe you could extend it to do that. I haven't thought about it.
And then there's a question of indentation. I mean, I've written some Emacs modes that does indentation, but I never want to show the code.
Yeah, that's a very good question. So you can see some of these extra annotations after some of the rules. Like for parents, it says context, which means as long as you're in this production, save some context about where it started and what kind of rule it is. And then there's style number and style variable, which are obviously just style these with this given name, which then gives them a color in the actual output. But yeah, I've written indentation functions as basically as functions from context to a number, the amount of indentation, and that works relatively well. You still have to do quite a lot of obscure things, like if an opening parenthesis is followed by some text, you'll probably want to indent the rest like aligned to the parentheses instead of indented a bit relative to the start. But that works quite well. So that's why I said that this tracking of context, of which rules you're in, is very useful also for other kinds of tooling. So where was I?
I was wondering, are there any tools to deal with debug partially extension grammar that supposedly you need 400 of them for both languages?
Yeah,
So
and
maybe some tooling around it.
yeah. So since I think I'm the first one to try to seriously use these for highlighting modes, there's not much tooling, and they are a bit of a pain to debug. So I've been writing some ad hoc helper things. I think they would lend themselves to relatively good tooling where you can just like provide an example where it goes wrong and see exactly how it parsed that, and then you can usually figure out what you did wrong. But it doesn't exist yet.
I'm familiar with one project from this something home, right?
Ah, yeah. I was inspired quite a lot by that for this.
Something like that. Is there any
That's really a parser in the classical sense, so they're doing something quite different. And I'll get into why my parser works very differently in a moment. Yeah, I took inspiration from them, but it's not something you can directly apply to the kind of grammars I'm using.
Maybe you'll get to that in a moment, but can you say a bit more about how WYSIWYG works, which seems much more important for this than
How what works?
how WYSIWYG works? Continuing to parse after you encounter an error, and then I mean you want to have the highlighting work even in the face of say an unclosed waiting.
Yeah, I'll get to that later. I need some more context to explain how that works. Yeah.
Was one more question?
Yeah, but I wanted to ask the same thing.
All right. Yes.
So there's been a debate about the utility of just purely syntactic highlighting versus semantic highlighting. You talked a little earlier about being able to say distinguish between local variables and global variables. But do you see a path to being able to distinguish between, say, variables that have been ascribed different types? And then how do you feel about the
I
debate
think that needs more heavyweight tooling and very, very language-specific tooling, because it's like it involves for many languages type inference and stuff like that. So that's out of scope for what I'm trying to do here. I think it's usually you do want a very quick, simple highlighter, and then you can build stuff on top of that, but that shouldn't necessarily be responsible for the highlighting, because if you want to build up real accurate abstract syntax trees, for example, you don't want to do that synchronously as the user is editing. You prefer to do that in the background. So I think these are best conceptualized as two different tasks.
You said you're saving the state for every line where you're going to this validation?
Conceptually, the editor doesn't actually do it at every line. It just does it every n lines and then scans backwards when it needs a given state.
Okay, so and how much memory does that take to use in practice, or is this a problem?
Depends on the state, but I haven't really found it a problem so far.
More questions?
Okay, so one issue with this is that the standard parsing algorithm for parser expression grammar is a kind of backtracking thing, where if you see X or Y, you first, you remember where you are, you try to parse X, and if that fails, you go back to where you started and you try to parse Y. So you have arbitrary backtracking. In fact, most grammars' top-level rule will look something like statement star. And if your whole file is a single statement, you aren't sure that you're actually, that your current parse is the right parse until you've parsed the whole file, which is of course unacceptable, because you want to immediately start outputting styles without first parsing the whole file and on every change reparsing the whole file. So we need to change the semantics of parser expression grammars in a very crude and scary way. Namely, what I do is I first distinguish between parts of the grammar that are regular language, so which could be matched with a regular expression, and those that aren't. Like if you have a recursive rule, there's no way you can match it with a regular expression. Also, these rules that actually denote a token, they need to be separated, because they need to be their own thing, because they have to embed this token information. But all the other things like digit and letter, it can just be inlined, and then you have in expression we can inline the whole content of num and of var to just be part of that, be a single edge in that expression. So we compile it to a graph, something like this, where the small detailed lexical level things get inlined into bigger rules. And that is already quite close to the format we saw before. But you do have the issue that you, when you write these grammars, and this is the main issue I have with my solution still, you have to keep in mind how much of this is regular. Does this actually disambiguate from the current point? And if not, you have to manually insert look-aheads to figure out, to make sure the right branch is taken. And I tried to look into solving that by automatically finding ambiguities, but the problem is that some ambiguities are actually intentional, because you do want to, sometimes you do want to have, this is like how partial expression grammars work, sometimes you do intentionally need the first one to match even though another one could match, and sometimes it's an accident. So I'm still looking about for like syntactic changes to make this more obvious, but it's workable. I only had one such bug as I was actually working on a grammar. So it's practical even without this, but this is definitely suboptimal. But if you have this like simplified graph, you can output it in a format something like this, though mine is more graph-oriented rather than stack-oriented. And then you can have an interpreter which keeps like a stack of active, which are like nodes in this graph, like points where you are. And so it's like not a regular state machine, but a state machine that builds up a stack as it runs through a single rule, like these. Each of these subgraphs has a red node where it's like returning from the current rule to whatever pushed it onto the stack. And alongside that, the state needs to keep track of the context. So for example, I specified that this parents production is a context. So whenever it enters that, it pushes some stuff onto that context stack. And that's all the state it keeps. And each time it needs to really token, it just moves forward until it finds an edge that actually advances the stream. And then at that point it commits to the edge, so that's considered like the direction this parse is going, updates the state and returns a token.
So, more questions? Something? Because you guys didn't even use 5 minutes, where mine already went 2 minutes over.
Which is good, because I wouldn't have gotten half to the talk in those 20 minutes.
Do you always invalidate to the end of the file when a change is made, or can you invalidate to, say, the next time the state of the change?
No, that's hard to determine whether you could like reuse an alt state at a given position. Although actually, if you have so far CodeMirror states were just like hand-rolled stuff from widely different programs, so it was hard to compare states. But if you have a compare state function, you could actually, that would be a really great optimization. You could say, okay, I've arrived at the same state, so I'm just going to stop working.
Yeah, like
yeah.
in the middle of an expression, and then you know that you're not changing it. You haven't inserted like a closed brain, then you can still reparse that expression without having to recall the rest of the file.
Yeah.
Seems like it'd be especially useful in the case of collaborative editing, when you've got someone changing the first line and you're way down to the middle.
Indeed. Yeah, that could save a lot of work. Yeah.
Can you estimate on the regex file function and the rest? How that's roughly time or
In performance.
you know, like is it what is
The handwriting a tokenizer is probably always going to be faster than matching a bunch of separate regex one by one, because you can usually dispatch on the first character and do much less work. So that is faster. Like in my benchmarks, about 3 times faster than regex-based solutions.
the regex only work on the Q port, the express version, so you actually just perform on the current Q port?
They just get a few lines of input in my system, because you're supposed to tokens shouldn't be bigger than a few lines anyway, so they're kind of limited, because also JavaScript regex, this is all written in JavaScript, are terrible in that you can't match them lazily, like start on some substring and then when they reach the end feed them more input, so you always would have to concatenate the whole document, which is a 3 data structure, so that's a practical concern. I can't give it the whole document. So I want to quickly get back to the error tolerance. What I'm doing here is that when it can't make progress, when it, for example, gets stuck in a node and none of the edges that go out from there match the current input, what it'll first do is it'll try to like basically insert tokens by skipping edges. Like it'll skip an edge and see if from the next node out it can match some of the input. So that in that case, for example, if you have a missing closing parent or a missing closing brace, it'll randomly happen to skip that edge with, well, usually it'll be one of the nearest edges. It'll skip that and see if it can make progress after that, and if so, it'll do that. So like it basically inserted a conceptual token there. If that doesn't work, it'll try the other way, like skipping pieces of input. So you can mark some of your rules as like base tokens in the grammar, and it'll synthesize a big rule with all these base tokens with or operators between them, or any character appended at the end as a kind of fallback, and it'll just push one of those onto the stack when it can't make progress otherwise, which means that at that point it'll just parse something that may look like a string or a keyword or whatever, and color it properly, and then it'll try again to make progress after that. So it'll just basically discard pieces of input but still color them. And that works relatively well. So that would also solve the closing quote for the string thing, because strings are usually built out of multiple edges. And the closing edge could be discarded to if it's not there. Although if it's a multi-line string, it would prefer to just parse the rest of the document as a string. But that's maybe the expected thing to do if you don't close a multi-line string.
Any more questions?
So what about white space sensitivity?
Yeah, that was my next slide. That's a big problem with scannerless grammars, that white space has to be in there somewhere. So you could either, in every of your rules, insert white space, something, white space, something, white space. So that's very cumbersome. Another convention that's often done is to tack it to the end of all of the like leaf rules, the token style rules, which doesn't work in my case because I have to, like I use the matching of a rule to color something as a, say, a keyword, and I don't want to color the white space after a keyword as a keyword. So I took a hint from Alm there as well. They have a special kind of rules, like they distinguish between syntactic and lexical rules. And in syntactic rules, they just insert a given white space expression, which is this like skip white space syntax that I have here. All the rules that are inside the skip white space block have this expression white space inserted between every like sequence operator and in repeat operators after the repeated expression, and that causes it to basically end up in the right place and be skipped at every point where you want it to be skipped.
Any more questions?
Do you limit the import online time? For example, if you open a unifying JavaScript?
Not currently, but that's a big design problem in my editor and a bunch of other editors. That line granularity is just problematic. It's not a good way to like limit work. This is my last slide. So I did this quick like file size comparison between like the basic Vim C++ mode is very, very crude. So I searched for like third-party C++ mode that also tries to highlight things a bit more thoroughly. And they came to 82 kilobytes. Sublime Text standard C++ mode is 60. My C grammar is 4K, and my extension on that is another 4K. So this is definitely more succinct. Whether it's also more pleasant to write, I'm not entirely sure yet, but you do have to write a lot less. And if I compile it with my tool, I get a 22K graph, which is unreadable, but also very compact. So that's looking relatively good. I put it on GitHub, the lowermost link. It's not very polished yet, but it works, and I'm using it to deliver some modes for a customer, so it should work better in the future. Yeah?
This is kind of out there, but have you considered being able to write a generic tool to build something that will reflow, like time format, for example, doesn't actually parse C++. It just sort of looks at it sideways and tries to reconstruct its own code.
I don't get the question, sorry.
Have you considered extending this to be able to write a generic tool to write
No, I've written a code reformatter in the past. It was a huge pain. I think it's a different problem again because the grammar doesn't really say where the new lines should go or stuff like that. Like if you have the new lines already, re-indentation is kind of in scope. So I usually write an indenter along with each mode, but finding places to put new lines is another problem, I think.
Other things, but this was a little bit of innovation, mostly highlighted. Other stuff like matching delimiters, which is simple for parentheses and brackets model. But let's say you have like Ruby that ends things by writing end.
Yeah.
Or selecting the current thing I'm in, where the current thing I'm in could be a
Yeah.
definition or a function or
Yeah.
whatever.
So it's I'm not currently using that, but it would be a rather obvious extension to like track scopes as you're running the grammar over that and keep it like data structure or hierarchical. I'm already building up the data structure, but I'm currently discarding it again. And you could keep that around and use it to do things like that. Indeed, it would make it easier to match some non-trivial things rather than running a regex backwards and things like that. But for example, if you want to select expressions, usually these kinds of things ignore operator precedence because it's a pain and it's not necessary for highlighting and you'd have to write your grammars differently. I'm not sure how hard that would be to get operator precedence right in terms of expression size. All right, I said we have a few more minutes, I think. I am out of slides.
What do you compile your code to? You have compiled output on the...
Yeah, I can try to show it. So it looks something like this. These are shared edges, and then here you have your. Oh no, these aren't. These are statements like. Oh no, tokens. This, like I thought that you can mark things as being a token. So this is the token fallback. If it can't match anything, then here we get preprocessor line, white space, and this is the non-compact readable format. The other one uses numbers for node names and deduplicates edges, so you can't read that at all. But here you can kind of see a statement can be a class, and then it goes to statement 1. Which is back here, it matches white space after class, goes to statement 2, and then it figures out some align S syntax, continues to statement 4, and so on and so on. So the grammar itself for, so it starts by saying that it extends the C grammar, and then it's here it's basically defining the statement that we just saw the graph for. Probably it's just JavaScript, so I guess, yeah.
Okay, one last. Speaking practically, it's a web-based editor. Do you feel that web IDs are the reliable solution? Is that the intention here?
I think so. So, I mean, they're definitely useful, even if you don't use it in an IDE. Like just providing a decent code editor on a web page is often a useful thing to do. I mean, web technology has a long way to go, but on the other hand, it also does a lot of things right that desktop editors often still have problems with, like advanced Unicode magic and stuff like that. You just use the browser framework. I hope that WebTech continues to get better, but it's definitely slower because you're limited to, and one big problem is also that you can't really ship a compiled version of a Unicode library to a browser, so you don't really have a Unicode database, which you actually need to provide a good editor. So I think that's the main stumbling block, but there's also standards work ongoing to actually, I mean, all browsers have a Unicode database, so they could just expose that to the JavaScript somehow. I think we're out of time, or can we do another? Possibly. Yeah, if you have just a stupid interpreter running a simple input format, that's probably a great example of something that can be compiled to WebAssembly. Currently, marshalling data between JavaScript and WebAssembly is a bit of a pain, so that might still make it relatively inefficient, but they're working on that. It might at some point become a useful strategy. Done? Or? Okay. Thanks for listening. Screen full, and then as you scroll down you can like slowly continue highlighting. This is all still relatively like incremental. You don't have to do a lot of work in one shot, and when the user makes a change, say the red line changes, you throw away all the information below that change and take the nearest state above that change and continue to the end of the viewport from there. So this has a nice property that if changes happen within the viewport, which is the case at least 90% of the time, the work you have to do is bounded by viewport size, so you don't have to do, and you can usually just do it synchronously as you refresh the screen. Because it doesn't always hold up, say you're looking at the bottom of the view and you have a collaborative editor and someone else is changing the first line. So you do want to set things up so that this work can be done in the background, and the user can keep on editing as some background process is catching up to the code you're currently editing. You can usually even cheat, like highlighting is somewhat state dependent, but not hugely state dependent. So if you are at the bottom of the document and you want to draw something, editors to look. Specifically, the syntactic elements of the language that you're writing are color-coded, so to say, are highlighted in different colors, giving you an additional source of context as you're reading the code, whether a given word is a variable, a type, part of a command, part of a string. And how these kinds of highlighting code like this in an editor is a problem in itself. People are expecting quite a lot from their editor these days. Like they're not just supposed to highlight strings and keywords anymore. They should also do context-sensitive things, like whether something is a type or a regular variable, whether it's a local variable or a global, and so on and so on. So yeah, defining these is not entirely trivial. Especially since if you're writing an editor, you don't have to deal with the quirks of one language, you have to deal with the quirks of every language. And while programming languages do tend to follow a certain kind of disciplined grammar structure, most of them at least, every minified file or something, but that's what a lot of editors do. So if you have, say, a command that's 1,000 lines long, you want your parser state to be stoppable even in the middle of this, which you would conceptually consider a token. You can't just go one token at a time, basically, in the traditional sense. And of course, it has to be error tolerant, which I'll get back to later. One way to conceptualize such a highlighter is to see it as a function from a given state and an input position to a token, which is like a little piece of this input with styling applied, and a new state after that token. And then you can just repeatedly call this function as you iterate through the document, and occasionally set aside a state for later resumption. I made a little animation which is trying to show this. So here you have a document. The blue stuff has been highlighted. The black rectangle is your viewport, so as you start up, you're only seeing a little piece of the document, so you don't want to go off and highlight the whole thing, because it might be 20 megabytes and the user might never look beyond the 5th line. So you start by just highlighting the first single one. Has some weird exceptions and weird rules that don't fit into most generalized parsing frameworks. So This isn't trivial. CodeMirror comes with support for, which is my editor, comes with support for over 120 different languages, with some of them having a bunch of sub-dialects as well. That is quite a maintenance burden, and thus I set out to try and find a less error-prone and more convenient way to define these. In a way, these are parsers, as in they do a lot of the same work that a normal parser that you might find in a compiler does, but they have very different constraints. So a file might be big, but instead of parsing it in one go, you'll have constant localized edits, usually around one place. And like, it's not necessarily a parse tree, but a token stream, it has to be updated for every change, quickly preferably, because yeah, you don't want to freeze the interface that the user is using. People also find it annoying if it's like black for a few seconds and then flips into coloring. So you have to be able to respond to localized changes immediately. The input will often not be valid. As you're editing a text file, you're not going to have it in a syntactically valid form all the time, and you still want highlighting to more or less work, even if you make a mistake. I think every editor has a solution that relies on incremental parsing. So you have your parser state as a value that you can save and that you can resume multiple times, so that you keep your parser state at different positions in your document, and as it is edited, you just resume the nearest state and parse from there instead of always starting from the start. Of course, saving all these states has to be relatively low memory. You can't save a giant data structure X times. It's just, it's going to take up way too much memory. One requirement that is more cumbersome than it might initially sound like is it has to have a low granularity. Many editors use end of line as a resumption point. Which is not an ideal situation for the reason that a line can be several megabytes long if you have a weird